In example 15.2, we're asked to demonstrate whether bar forces BE, BC, and AE are in compression or in tension. This suggests that we don't actually have to, unless it's necessary, go through and calculate numbers, but rather attempt to do so somewhat conceptually. The members again that we're after are AE, that's a bottom chord member, the diagonal BE, and the top chord member BC. When I see something like this, three members only that I'm after, and I can go through and cut all the way through the structure and cut through all three members that I'm interested in, that suggests method of sections right off the bat. You'll see down below here as a first step, I can then, through our three global equations of equilibrium, figure out exactly what each of the reactions are. We see, and some of these are somewhat trivial, such as AX is the only X component of all the reactions, so it has to be equal to the net of all the lateral applied forces. There's only one, 3, so that one becomes somewhat trivial. And then through some moments either about A or D, I can find out what the values are of AX and DY being, AY and DY being 1 and 3 kips respectively. Right. Now, it would have actually been easy to show conceptually by some moments about A that dy has to be going back up because it's the only thing that can spin the body in a counterclockwise fashion about point A, and all the applied loads are going in the other direction. So dy has to be going up. The only question is just how big or small is it? Is it larger than the 4 or not? Because by sum of forces in the y, AY is the difference between dy and that 4. Right. So let's go do this method of sections that we have now that we know what the reactions are, and see what we can get out of that without actually doing any direct math. Now, there will be symbolic math in some kind of sense, but we can actually get a pretty good feeling for what's happening by just looking at the free body diagram and conceptually what we think really has to be going on in this case. Right? The applied loads are 3 kips laterally up at the top at joint B, and then we have at the joint A, we just found that was 1 kip going up, and then we have the reaction AX of 3 kips going in the other direction. Right? So that tells me that since I've got 1, 2, 3 members that all have horizontal components to it, somehow they're going to have to be self-equilibrating in a sense, meaning that whatever values they are, they have to sum to 0 all by themselves, because I already have a 3 going in one direction and 3 going the other horizontally. Right? That same idea, actually take a look what happens here, that BE turns out to be the only of these 3 members that has a vertical component, and there's only one other force that is vertical in orientation on this free body diagram. So that tells me right off the bat that through this panel there has to be a 1 kip going downwards for equilibration. That's a sum of forces in the y direction, and since BY is the only one that is like that, then I already know right off the bat that the y component of BE has to be equal then to this net of 1 kip. That also tells me that it has to be acting downwards, or in other words, it's pulling away from the free body diagram. It's in tension. Okay, so to finish that, well, I don't really have to go much further to get what I want. I know that it's got to be in tension. Now, I can figure out what the orientation of this member is, and I think we have another 3, 4, 5 kind of triangle here. There's the 8, and I come through here, bisect it. That's a 6, so 8 on 6, so that's a 4, 3, 4 run over 3. Sorry, 4 rise over 3 run, and so it would turn out that BE is going to be equal to 5/4 of 1, or 1.25 kips. All right. Didn't really need to do that part because I could demonstrate already what had to be the case in terms of summation of forces in the y told me that BE had to be pulling away from the free body diagram for vertical equilibrium. Right, so that gives me that. Now the other ones that we want are AE, that's down here at the bottom, and BC, that's up here at the top. And usually when you're doing these, what you'll find is that you can sum moments about one of the other joints. Maybe it's that joint's on the free body diagram, maybe it's not. If I look at joint E, well then AE passes right on through there, BE there, and although I expect that AE is going to be in tension, I don't know that yet exactly, and it is going to turn out that it will be. I can also maybe anticipate that this top chord BC will be in compression. That's what I'm suggesting. Let's look at what happens if we sum moments about point E and see whether or not that is going to bear out to be the case. I'm going to take counterclockwise as positive because that's the same direction as BC would be going. Its moment arm with respect to E is 8 foot, so 8 times BC minus 3 times 8, so that's the top chord force. The reaction AX passes right through E, doesn't get included. The one kip reaction at A also makes a clockwise rotation, so that's 1 times, well, let's see, that whole moment arm is 12. And then let's see, BE and AE pass through E, so I'm done. And it does make it very clear then, and in a very simple kind of way here, not only that BC was chosen directly, it has to be in compression, but the math actually turns out to be pretty easy here as well. 24 and another 12 is 36, so we have 36 divided by 8, and that would be 4.5 kips. Again, as shown, that would be compression. Over here, BE turned out to be in tension. Right? So that gives us 3 of them with numbers, or 2 of them with numbers, that is. And for the last one, then, we want AE, so why not some moments about point B? And here I'll take, now, again, counterclockwise is positive. I'll have 8 times AE for its moment arm. I'll have a minus, then 1 times the, let's see, that moment arm will be 6, right, because that's a 12-foot panel. This is not drawn well to scale at all. That's 6 foot there, 6 foot there. And so we get a minus 1 times 6. And then I also get now AX, because I'm summing moments about B. That will be a minus 3 times 8. And once again, note that that makes it very apparent, even without doing the rest of the math, that AE has to be in tension. And we could stop almost right there. AE is a positive number. As shown here, the specific number will be 6 plus that 24, so that's 30. 30 divided by 8 then for the net, and that will be 3.75 kips, and as shown, that would be tension. Right? So that gives you numbers as well as what we were just asked to do, but we get a compression, we get a tension, and we get a tension respectively as we go from BC, BE to AE.